This is a video lesson for Module 5, Lesson 11. The Lesson 11 learning target is I can explain fraction equivalence using a tape diagram and the number line and relate that to the use of multiplication and division. So in this lesson we're going to be looking at a new strategy for representing fractions, the number line, and we're going to be connecting it to some of our old strategies that we've been using so far in this unit. So let's go ahead and jump into it and get started. So the first problem here, we're going to be looking at a tape diagram that represents the fraction 1/2. You can see that it's 1/2 because there are two parts total in the tape diagram and one part is shaded in. So we know that this is 1/2. But to represent 1/2 on the number line, I'm going to start by labeling 0 down at one end, or 0 halves I should say, and then 2 halves on the other. So this is the same as 0 and 1 whole on the end over here. And in the middle, right below this half partition right here on the tape diagram, I'm going to mark a little line that will represent 1/2. So you can see that I have made this 1/2 mark 1/2 way between 0 halves and 2 halves. So this number line strategy is very, very similar to the tape diagram in that it's marking specific points where specific fractions are. So if we were to continue to partition our original fraction of 1/2 in the tape diagram, let's say we went ahead and split it into fourths. So cutting both of the parts in half. So now we have twice as many total parts and twice as many shaded parts. To represent that on our tape diagram, we simply do the same thing of representing different amounts at different points on the number line. So we would have 1/4 here. 2/4, of course, equal to 1/2. 3/4. And of course 0 and 2 halves are the same thing. Actually, I'm going to go ahead and change that now. They're actually just the same as 0 and 1 whole. And that's the same for 4/4 and 0/4. That's the same as 1 whole and as 0. So you can see that we can show this equivalence because 2 halves is in the same spot on the number line as, 2/4 is at the same spot on the number line as 1/2. These two are exact same spot right here. So that shows us that these two fractions are equivalent. So if we continue partitioning our tape diagram here, let's say we go all the way down to eighths, splitting each section in half here. We've once again doubled the number of total sections, so now there's 8. And we've doubled the number of shaded sections, so now there's 4. And we can continue to fill in our number line here. So for this time, we'll be able to see some more equivalent fractions. So all I'm doing is I'm following along the tape diagram, so I'm looking at the lines and I'm kind of looking down to see where I would put this on the number line. So that's all I'm doing to fill in these values. So, the 1/2's getting a little crowded here. So it would be 4/8, 5/8, 6/8, and 7/8. So you can see that we found some more equivalents. We've got 2/8 equaling 1/4, 6/8 equaling 3/4, and we found an additional equivalent fraction to 1/2. So now we have 4/8, 2/4, and 1/2 all being equal. So that problem was all just about looking at this new number line way to represent equivalent fractions. And so now we're going to actually look at how we can use the number line to show equivalency with multiplication and division. So let's go ahead and move on to problem 2 down here. So in problem 2, I'm going to be looking at the fraction 1/3. So I'm going to show that I'm representing 1/3 by putting a little dot on the number line right at 1/3. And what I'm going to be doing is I'm going to be partitioning the space between 0/3 and 1/3 into 4 equal parts. So I'm going to go ahead and do that now. I'm going to split it into 4 equal parts. So there we have it right there. I've just split the section between 0/3 and 1/3 into 4 equal parts. And to figure out what fractions I've now represented here, I'm going to show a little bit of multiplication. So what I've really done is I've taken 1/3 and I have multiplied the numerator and the denominator by 4 because I've split it into 4 equal parts. And so this gets me an equivalent fraction of 4/12. So I could be representing my thirds on this number line in twelfths as well. So 0/3 is of course 0/12, 1/3 would be 4/12, 2/3 would be 8/12, and 3/3 would be 12/12. So I can find equivalent fractions pretty simply in that way. And of course also 4/12, if we were to divide the numerator and the denominator by 4, we can show that equivalence that way as well. So splitting up equal parts in our number line is a way that we can show equivalence between two fractions. In this case, 1/3 being equal to 4/12. So let's go ahead and take a look at one more problem that we're going to be doing. Kind of the similar thing, showing equivalence with a number line. Now in this problem, I'm going to be looking at the fraction 2/5. So I'm going to be looking at the space from 0/5 all the way to 2/5. And this problem is going to be a little bit trickier because in this problem I'm going to be splitting that space between 0/5 and 2/5 into 6 equal parts. So I'm going to go ahead and do that right now. So I've split it into 6 equal parts now, and so I'm going to be looking for an equivalent fraction to 2/5 based on me splitting that space into 6 equal parts. So what's going to help me in this situation is to see how many equal parts were split in just one unit, a single unit. So how many equal parts is 1/5 being split up into? And if I look and I count, I see it's 1, 2, 3 equal parts. So this shows me, or this tells me in fact, that I am going to be multiplying my numerator and my denominator by 3 to find an equivalent fraction. So I take my numerator and denominator 2/5, and I'm going to go ahead and multiply those both by 3, the same number. And that's going to get me the equivalent fraction of 6/15. So what I've done here is on my number line, I've actually shown equivalence of fifths and 15ths. So 0/5 is equal to 0/15, 1/5 is equal to 3/15, 2/5 equal to 6/15. And we can continue on repeating this pattern with 15ths. So once again, we're able to partition the space in the number line and show equivalency, and then back that up with our multiplication as well. So at this point, you should be able to tackle all the problems in the Lesson 11 problem set. But as always, if you get stuck, you can come on back and rewatch any parts of the video to help you out with any of the problems you get stuck on. Thanks for watching.